All right, now this is pre-calculus. This is Unit 6 review. This is part 1. We're going to do the first 2 pages. All right, I'm going to start with problem number 2. So it says, sketch the vector with the given bearing. Make sure you label the vertical reference angle phi. If I look at number 2, it says 40 degrees west of south. So we're going to make west, south, those are our 2 cardinal directions, and we are going to draw a vertical angle. This is a little bit lower than halfway in between them, and make that 40 degrees. Label this vector A, and we are done. So that is the vertical vector phi. In number 3, true north means we're always starting at the vertical axis and we want to go clockwise. So that means we're going to start right here. That's our true north 0. And we're going to go all the way around. This is a little bit further than 270 degrees. So that means that angle right there is going to be 295 degrees true north. And that's vector A. So numbers 2 and 3 are done. Number 5, given the magnitude and direction of each vector, find the horizontal and vertical components. This is going to require us to use sine and cosine. Now in this particular vector, we have a right triangle that you make with the horizontal axis. So anytime you have this question, always make the triangle with the horizontal axis. X is going to be r cosine theta. Y is going to be r sine theta. In this case, r is going to be the length or the magnitude of the vector, so 13. X is going to be 13 cosine. But be really careful about the angle that you use here, because if you use 70 degrees, that might get you in the right or wrong quadrant. It will probably put you in quadrant 1, so that's going to give you a bad component because you're going to have the wrong sign. So what you really can do here is always use theta from the horizontal 0 degree axis. And that means that 360, if this angle is 70 degrees, that's the vertical, and that means this is 20. So that means that we should be doing 360 minus 20, and this angle is 340 degrees. So if I use that as my theta, I'm going to go right to the calculator, and I can get 2 answers here. So 13 cosine 340, that gives me positive 12.216, so I'll make that 12.22. And then for the y coordinate, negative 4.446, so I'm going to write negative 4.45. Okay, so notice using that 340 degrees gave us the exact correct answer. So the component form here should be 12.22, comma, negative 4.45. All right, so we are done with question 5. Let's get to some of the more difficult ones. For example, number 6, a javelin thrower gets a running start of 8 miles per hour, throws the javelin at a 38-degree angle. The javelin itself is thrown with an initial velocity of 70 miles per hour. Find the resultant initial velocity of the javelin. So let's start by just saying, okay, if somebody's running 8 miles per hour, they're running in a straight forward direction, horizontal. At the point where the thrower actually throws the javelin, it's being launched at 70 miles per hour at a 38-degree angle with the horizontal. So because you can take vectors and move them anywhere you want, You could draw the vector here where it's actually thrown. You could move the vector here that way. But either way, we need to add the two vectors together. So adding the two vectors together, it gives us a resultant, which is this particular vector right here, resultant. Let's call it x. We can figure out the angle inside of the triangle by doing 180 degrees minus 38, and that's 142. So this is a perfect law of cosines problem, where x squared is equal to 8 squared plus 70 squared minus 2 times 8 times 70 times cosine of 142 degrees, the angle between them. You put that in your calculator and you solve for x. Don't forget to take the square root. You should get an answer of x equals 76.46 miles per hour. It makes perfect sense because if someone is running before they throw their javelin and they throw their javelin at 70 miles an hour, then the resultant speed would actually be faster than that. Here's a challenge problem for you. Suppose that Carl and David are both hiking from the same base camp. Carl starts at the base camp and walks 4 miles due west and then bears 30 degrees east of south for another 2 miles. Here's our base camp. Carl is going to walk 4 miles to the west. Now he makes a turn at 30 degrees east of south. What does that look like? Here are my cardinal directions: south, west, east. So 30 degrees east of south means that vertical angle, phi, needs to be 30 degrees. So I need to take that and move it and attach it to where Carl is. That's going to be right here. 30 degrees east of south. And he walks for another 2 miles. So that's Carl. David walks 3 miles south. And then bears 80 degrees west of south. All right, 80 degrees west of south. Here's west, here's south. 80 degrees means that vertical angle phi needs to be 80 here. So let's translate that and add it to where David is. So that means we're going to make a turn this way. And be very careful about where you put the angle. 80. And then he's going to walk for another 3 miles. The question is, who is farther from the campground, Carl or David, and by how many miles? We're going to use law of cosines again, where this distance in green here, this is going to be Carl's distance. This next green line is going to be David's distance. Try the law of cosines for each of them to solve, and then find the difference. All right, so that problem is up to you. Just be careful about what angle you use inside your diagrams. For example, your hint here is that angle right there, where Carl makes a turn, is 60 degrees. Okay, the rest is up to you. And the last one we'll do here in part 1, problem 9. Graph the points 1, -6, 6, 0, 4, -4 on a 3D coordinate plane. I will not ask you to graph the picture on a test. It's just for reference, so maybe it helps you, okay? So part A, I have to go out 1. Here's the positive x. I have to go out 1, left 6, and up 6. So left 1, out 1, left 6, up 6. Somewhere in space, a point A. For B, I don't have to go in or out of the diagram at all. And then I'm going to go 4 to the right, and then I'm going to go 4 down. So that's really on the ZY plane. So this particular vector starts out in space, out towards me, and then goes backwards into the iPad just a tiny bit, into the picture. B, the component form of the vector AB is given by taking each component, each coordinate, and subtracting them. So the x component is going to be given by 0 minus 1. The y component is going to be given by 4 minus negative 6. The z component is going to be given by negative 4 minus 6. That should come out to negative 1, 10, negative 10. And we're done. Part C. So part C, find the magnitude of the vector. Well, the magnitude of a vector once you have the component form is given by a squared plus b squared plus c squared, square root all of that. So the magnitude of AB is going to be given by negative 1 squared plus 10 squared plus negative 10 squared, square root all of that. So that's going to be 1 plus 100 plus 100, and that's the square root of 201. Not a very nice answer. So we just have to leave it like that. I don't think it's going to simplify. And then we can move on to part D. Find the angle theta with respect to the horizontal plane. We're going to round our degree answer to the nearest tenth. Now this vector, which is hanging out in space, can be moved anywhere I want. That means I'm going to conveniently draw it starting at the center. And what happens is, it's going to be kind of hard to visualize, but that vector makes a right triangle in space in the backwards right-hand corner of the XY plane. So we actually don't want to use tangent. You can, but you would have to find right triangles, for example there, with the XY plane in order to use tangent and find different side lengths. It's much better in 3 dimensions to use the z coordinate here, which is negative 10, along with the magnitude of the vector, which turns out to be the hypotenuse in this triangle that's hanging out in space. That's square root 201. So what we want to do is notice that this is opposite. This is hypotenuse, and my angle theta is right there with the horizontal plane. So now let's use sine inverse of opposite over hypotenuse. Let's put that right in the calculator. That should give you an answer of negative 44.9 degrees. All right, so now it is up to you guys to complete the rest of the review. You have to also comment on this video in order to receive credit for the day. And do not forget to log in for attendance on the Google form. All right, have a nice day.